Okay, I'm going to work through one of these homework problems for you. We've got a pretty straightforward example. We've got a parabola, x squared plus 2x, and we're going to evaluate the tangent at -3, 3. So you can plot that if you want and see what it looks like, but I'm just going to jump right to the math of it. We're going to use the definition in this case, and this is what you've become a little bit familiar with, I hope. So what we do is we just take the actual function, and then we take the value of the function at our point right there, and we use x as a variable, and then we use the x value for our point right there as well. So we just write, well, this is going to be the limit as x approaches, in this case, -3, of, and it's our function, x squared plus 2x, and then minus the y value, the vertical value, the function, at f of -3. When I plug in -3, I get 9, plus 2 times -3 is -6, so 9 plus -6 gives us a +3, and then I'm subtracting it, and that is over then x minus our -3. Okay, well, this then just becomes the limit as x approaches -3 of, and if you notice, this is a quadratic, and we want to factor that because we cannot just plug in -3 here, because if I plug in -3 I'll get 0, and we can't evaluate the limit that way. But if I factor it, magic happens, so I get x plus 3 and then x minus 1. And if you FOIL that out, you'll see that you get plus 3x and then minus 1x gives me the plus 2x I want. And when I do a minus 3, I get x plus 3, and lo and behold, these cancel, and I just get x minus 1, which does not have the problem of division by 0. When I sub in -3, that's just -3 minus 1, which gives me -4 as my slope of the tangent line through that point, -3, -3. Okay? Okay, I've got just a little bit of review of what we've done in class here to develop our second equation based on the slope of a function as thought of as a secant line that has a point that's swinging closer and closer and closer to being on that fixed point here, and will give us our tangent to that curve. So if we've got some fixed point that's over to a in our x direction, and then up some amount that's determined by our function, so we plug in a, we see what that value is, and we're over a and up f of a. If we add on some arbitrary amount, in this case we'll just call it h, so if I go over h, I am now at the point for on my x-axis at a plus h, and then I go up an amount that's f of a plus h. Okay, so I evaluate the function with our extra little bit added on. Well, the slope of this secant line, that as this point comes closer and closer and closer, will become our tangent line. The slope is simply the change in the y's, so my y value there, taking away my y value here, so my f of a plus h minus f of a, that's my change in the y's, or the rise. And the run then is just this a plus h, and then taking away a, well, that becomes very simply h. All right, so you end up with this function, we end up with this equation rather, where the slope of our tangent line is going to be this rise over this run, and we'll see that is as the limit, as then our h value approaches 0. Okay, so we're going to go on and do that same example I did before, but using this equation. Okay, so we have returned to that parabolic function that we had in the first example at the same point, but we're going to use our new equation. It's pretty straightforward. You just have to pay attention to some of the details. We're going to start again with the limit as h is approaching 0. In our specific example here, this is the a value, and this is the f of a value. So I'm going to find then the limit as f of -3, then plus h, and then minus f of a is 3. So this is that h value that's going to get arbitrarily smaller and smaller and smaller. Well, when we plug in -3 plus h into our function for x, we're just going to square it and then add 2 times that. So this then becomes the limit as h approaches 0. If I reverse the order of this just to make it a little bit more conventional, that's h minus 3. H minus 3 squared, and then plus 2 times h minus 3, and then minus 3 for this value, and that's all over h. Then this will become the limit as h approaches 0. Well, when I FOIL this, right, this is going to be h minus 3 times h minus 3. You guys should be pros at this. This becomes h squared minus, you can pause me and do this, but it'll be that, and then 2 times this will be plus 2h, then minus 6 minus 3, and this is all over h. Well, you'll see that this becomes the limit as h approaches 0 of -6 and -3. That's a positive, that's a -9, and that cancels. This cancels with the positive 9, and then I just get h squared plus minus 6h plus 2h, so that gives me h squared then minus 4h over h. Well, this then just equals the limit as h approaches 0 of h minus 4. Oops, I just write that like that. Well, as h goes to 0, this just becomes minus 4. All right, same as before. I'm off the screen a little bit, so I'll pull that in, but you can see it just becomes, when the h's cancel here, 1, 2, and 3, I just get h minus 4, and as h goes to 0, that just goes away, and you get your answer minus 4. All right?